Welcome to my video on how to understand cockpit instruments. I'm Lawrence and a real life flight instructor, and if you haven't subscribed to my channel yet, please take a quick minute to do so and subscribe. And with that, let's get started. In front of you, you will see a basic setup for a small piston engine aircraft, usually the ones that you guys are going to be training on. What we are going to discuss today is the basic six-pack instruments, as it's referred to by the pilots. It's these six instruments right here in this block. We're going to go through each of them and then have a quick look as to what the radio stack entails and what all the other equipment we also going to use within our flights for within the next 18 exercises. Okay, so first we need to understand Pitotstatic System. A Pitotstatic System, it's instruments which are Pitotstatic systems which uses air pressure differences to determine speed and altitude. So these instruments is going to be our Airspeed Indicator, this one right here, then our Altimeter, this one right here, as well as our Vertical Speed Indicator. So let's take one for one now and gonna actually look how each one operate. The two instruments that I'm going to be focusing on today the most will be the Airspeed Indicator as well as the Attitude Indicator. So let's just zoom a little bit in for you guys to have a better view on this part. So the Airspeed Indicator shows the aircraft's speed relative to the surrounding air. This can be in both in knots as well as miles per hour, as this is currently mostly used around the world. The Airspeed Indicator works by measuring the ram air pressure in the aircraft's Pitot Tube relative to the ambient static pressure, thus giving us indicated airspeed. With this, static vents, which actually looks like a silver coin with a few holes poked in them, is then placed around the fuselage, usually at the back where the air is disturbed the less. In small aircraft like this Cessna, we have two. So what is a Pitot Tube that we're gonna first be looking at? So the Pitot Tube, if you look to your left, this is usually placed under your wing if you have a high wing aircraft, or if you're flying something like a Piper, this will be placed also underneath. During pre-flights that we'll get to, there's usually a red cover with a tag that says remove before flight, that you actually need to take off before flying, because this is what's happening. Relative airflows, the relative airflow actually or ram air flows within this Pitot Tube, and then with the difference pressures given from the static, it gives you your indicated airspeed as we are actually going through. As you can see, our airspeed indicator is color coded. Each color have a different meaning for our aircraft. Let's start with this section right here that is actually called the start of the white arc. This is called your VSO, meaning stall speed with flaps down. And if we go further where the green start, this is VS1, that stands for stall speed with flaps up as well. So this is up, flaps up, and this is without flaps down, also referred to as flaps retracted. Then this white arc that you actually see running all the way through here, this is where we can actually operate our flaps of the aircraft within a safe speed. if we near towards the end of that white arc, this is basically VFE, meaning that the max speed which we can actually fly the aircraft with flaps down. Then this entire green piece indicated on our airspeed indicator is known as VNO, the VNO is our max structural cruising speed for normal operations. So if you are flying within the green, then you are flying within normal operations. Now our yellow arc is our caution range speed, and this can only be flown if we are actually flying within calm and still air, but we always try and keep it within the green for good practice and safety reasons. Then the red line, that should explain itself. Red line means never exceed speed, or the how we pronounce it, VNE. So that's when you're then going to start experiencing structural damage from this part. Now moving on to the altimeter, to the left. Well, to the left you're going to see we actually have a few numbers, and to the right a few numbers as well. So this you need to have on any aircraft that you are actually flying. So let's look at what these small numbers within our altimeter is actually saying. So the altimeter shows the aircraft's altitude above sea level by measuring the difference between the pressure in a stack of aneroid capsules inside the altimeter case and the atmospheric pressure obtained through a static system. The most common unit for altimeter calibration worldwide is hectopascal. So this is the one that's being shown on the left, whereas in America and some parts of the world they use inches mercury. The altimeter is adjustable for local barometric pressures, which must be set correctly to obtain accurate altitude readings, usually expressed in feet. The barometric pressure reading, or QNH as it's known, is usually given to you by an air traffic controller. Later on in the exercises I'll show you how to get the barometric pressure, or QNH, if you do not have access to an air traffic controller. So typically what will happen, they will give you a reading. Let's say they're going to give you a QNH of 1015. You're going to then set your altimeter to a QNH of 1015, and then it will display you the feet above sea level. So as you can see, we are currently standing on the apron on the ground, but we are 5,000, just over 5,500 feet above sea level. So this is why it's very vital then to set your QNH correctly. So the long needle point indicates your feet in hundreds, where your small needle indicates your feet in thousands. And then you'll see you have this extra needle. This is actually displaying your feet in 10,000s. So that you'll actually start using when you're flying much bigger aircraft that goes to much higher altitudes. From here, the altimeter will go down to the vertical speed indicator. Now the vertical speed indicator, or VSI for short, senses changing air pressure and displays that information to you as a pilot as a rate of climb or descent in feet per minute. This instrument has a few seconds delay due to the pressure differences, and therefore should not be chased to maintain your straight and level flight. What I see with new students is, because this vertical speed indicator shows if you are flying up or down, they try and get the needle centered, but due to that pressure differential and the delay, it's actually very difficult, and therefore we will actually keep straight and level using the altimeter and the artificial horizon, but that we'll discuss in the flying straight and level exercise. So quick overview, currently showing 0 feet of climb or descent. There's your 500 feet per minute, 1000 feet, 1500 feet per minute climb, and 2000. And then the needle goes in opposite direction, 500 and 100, 1000 feet, 1500 feet per minute rate of descent. Now, just to finish up with our instruments, we say the Pitotstatic instruments. The Airspeed Indicator uses both our Pitot as well as our static, whereas our altimeter and vertical speed indicator is static driven only for those two. Moving on to our next 3 instruments. This is our gyro driven instruments. These instruments is our attitude indicator, our heading indicator, as well as our turn and slip indicator. Let's start with our attitude indicator. But before we go into the attitude indicator, let's just quickly see what gyro means. It says a gyro device consists of a wheel or disc mounted so that it can spin rapidly about an axis, which in itself is free to alter in direction. The orientation of the axis is not affected by tilting of the mounting. So, gyroscopes can be used to provide stability or maintain a reference in direction in navigation systems or automatic piloting and stabilizers. So that is why this is our gyro instruments. If you want to know a little bit more on gyros, you can read up on it for you. Okay, so the attitude indicator that we have here, it says the attitude indicator, also known as an artificial horizon, shows the aircraft's relation to the horizon. From this perspective, the pilot can then tell whether the wings are level and if the aircraft's nose is pointing above or below the horizon. So from here we can actually see it's now indicating straight and level flight. Whoops, just go a little bit forward from here. So if we look outside, we can see we are actually now in line with the horizon and our wings is level on both sides of the aircraft. When seated also in an aircraft, you want to put your hand on the dashboard and then count 4 fingers up to the horizon. So if you're seeing a screen, put your hands on the dashboard. So from here you're gonna have your 4 fingers up to the horizon, and that's gonna be the perfect seating position that you will need to fly an aircraft. Perfect. Now let's just look at a few numbers on our artificial horizon. So as you have noticed, there is a few lines drawn on your artificial horizon. The first line on top is going to be our 0 degree bank angle. So as you hear bank angle, meaning then it shows us how many degrees we are rolling the aircraft either to the left or the right. So starting with 0 degrees on top, then our first lines either side will be 10 degrees, with the second row of line on each side being 20 degrees angle of bank. Going to the third one is our 30 degree angle of bank, also referred to as a medium turn. And then This one right here is called our 60-degree angle, bank angle, and this one, as you guys will see, is our 90-degree bank angle. Well, and then if I tell you then to fly maybe something like a 45-degree angle, then just put this orange marker right in between the two lines and you should have yourself a perfectly neat 45-degree turn. Same works for your horizon indicator here. So just going up or down, there's 5-degree pitch down, there's 5-degree pitch up, and 10-degree pitch up. So this is where the artificial horizon comes in, and it will be flying a little bit on this as we go through the exercises, and so get yourself familiarized with where each degree or bank angle is to conduct the proper amount of bank for your turn. Okay, going down to your heading indicator. There's one right here. It says the heading indicator, also known as our directional gyro or DI, displays the aircraft's heading in compass points, as you can see, and with respect to magnetic north when set to the compass. So as you can see, it's got all the points of a compass. We don't refer in aviation as 21 or 210 degrees. We say it letter for letter. So south would be said as 180, and if we are flying, say, on this heading of where normal people will say 30 degrees, we are going to say 030. And if you're flying just off center of north, then it's going to be 003 degrees. So get into the habit of stating your directions letter by letter. What we're saying with align to compass, we'll get to the compass a little bit later. As you can see, the compass is showing 210 at the moment, but our DI is aligned for 115, and then we can see 210 is on the right. What are we going to do? Meaning we need to align our compass. We then turn it with this knob right here onto 21, and this needs to be set every 15 minutes when flying. Some aircraft has called what's called a heading buck that we can set right here. So say we are taking off from a certain point, we can set the heading buck right on top, and then we can actually fly and make sure we are maintaining that heading. Or say we're flying to a relevant point and thereafter we need to turn onto a heading of 120, then we can pre-select and set our heading buck for 120, just to assist us a little bit with the turning from there. Perfect. So both the attitude indicator and our heading indicator needs a vacuum to function, also written here on your attitude indicator. This is achieved by an engine-driven vacuum system that provides suction to operate these gyro instruments. So this is where the suction is generated from. Going on to our third and final gyro for today. This is called our turn and slip indicator. It's got a dual function. As you can see, basically we've got a ball and a little aircraft. So let's start with the turn and slip indicator. This is this ball in the middle right here. It indicates whether the tail of the aircraft is skidding out or slipping in towards in or out of a turn when we are actually generate or creating a turn for the aircraft. The purpose of this instrument is to actually keep that ball centered with your rudder pedals that's being displayed here. We've got a nice saying that says step on the ball. This means if the ball goes out to the left, you then apply left rudder and the ball will then come back in towards the middle until you've actually completed your turn from that part. Fantastic. Then going on to the turn coordinator. The turn coordinator, always remember this is also a electrically driven instrument. As you can see, there's also showing it's off, so whenever you have an turn coordinate failure and you're still flying and you experience this off flag, then this means it is unserviceable, therefore you can't use it. Now the turn coordinator shows us rate 1 turns or 15-degree turns. So if I'm turning the aircraft to the left, it will then turn and put this little wing part on the left for 15 degrees. However, this is only limited towards 15 degrees. It also serves as a backup system for my artificial horizon. So should my artificial horizon fail due to a vacuum failure of some sort, I can then fly on the turn coordinator to still keep my turns relatively at a low angle of attack and just in a very safe manner to fly. Perfect. Moving on to the compass. Let's just get a bit of a closer look. The compass shows the aircraft's heading relative to magnetic north. Errors include variation or difference between magnetic and true direction, as well as deviation caused by the electrical wiring in the aircraft. So because of this, you will in any aircraft, the compass, you'll get what's called a compass card. They say if you need to fly heading 060, you need to steer 061. This is then just to keep you on the correct path due to the Earth's magnetic fields as well as all the magnetism of the aircraft that's being experienced. Coming down to these two instruments, this one on the top, and this is what's called your very high frequency omnidirectional range, or VOR indicator for short. This is your main one, and the second one serves as a backup or standby. This we're not going to use until the end of exercise 18 and in your night flying, so for now we don't have to go into too much detail. Basically, to put it in short, there's beacons placed all around the world. Today, before GPS, these VORs would send out signals, and then you would fly with the signals or towards this VOR using one of the signals. And before the age of VOR, we have this system here. It's called a non-directional radio beacon, or NDB, which makes use of an ADF beacon. So first what came was the NDB, then the VORs, and then the GPSs, but still VOR widely used for today. Okay. Coming to the left is our RPM settings. So also the green is where we function. We'll get into the power settings for each exercise that we're gonna conduct. But the main purpose, what you need to always look out for when flying aircraft, you're gonna see these numbers situated right here. This is called your tacho. This is where the aircraft is being serviced. Every 50 hours and 100 hours, any aircraft needs to go in for a fuel change or a checkup with a major service, if you want to put it this way. This can be then found when it should go in your flight folio, or most aircraft maintenance guys just put a nice sticker for you here to actually check. So always before a flight, check that your tacho doesn't exceed your maintenance hours. From there on, you also have a secondary counter. It's called the Hawks. This is found in any aircraft where it actually measures your actual flight time. So as soon as the aircraft starts, the hops will start counting until shutdown. And this is how we determine our actual flight time and how you can look your actual flight time. Coming into the far left of the cockpit, we've got our fuel tanks. Make sure it is displayed in gallons or liters, so you know actually what is working. So when you're actually looking at the pilot manual, if they talk about your aircraft is using 6 gallons per hour and it's written here it's in liters, then you have to know you have to convert it. So left being your left wing and right being your right wing, where the fuel is being stored, or avgas for this matter, 100 LL that we're using here in South Africa. Your EGT, exhaust gas temperatures, as well as our fuel flow, just to confirm we are actually getting fuel flow. Same thing with the fuel. As you can see, this airspeed indicator is made in knots. Sometimes it's in miles an hour, and then you get dual airspeed indicators that will also show maybe miles an hour or knots on the outside, and then knots or miles on the inside. So then you have the best of both worlds. Okay, fuel set. Amps, this is just our battery charge or discharge. When we get into the startup, we're looking for a positive charge. Anything showing a negative charge will shut the aircraft down and have maintenance have a look at it. Also, when you start up and you experience a voltage load of more than 30 amps, then there's too much load on the system, then this also require a shutdown for and a maintenance check. Then VAC stands for vacuum. As you can see, we're basically operating Cessnas between 4.5 and 5.5. If you don't have a instrument like this, sometimes this is split in two, so then you will find your vacuum or amp meter just around the cockpit. Then your temperatures and pressures of your oil, we're gonna look how we gonna function or look at that when we actually do the startup of the aircraft tutorial. Then we've got all our circuit breakers. If a circuit breaker is popped, you are allowed to push it back once after 1 minute. If it then pops out again, you are not allowed to push it back by civil aviation authority regulations according to the air law. Magnetos, we've got dual magnetos. This is basically for that drives us. We've got a left section for our engine as well as a right that you can also read on a little bit more on your aircraft general. Then we've got our aircraft master switch as well as our alternator, and then we've got continuous circuit breakers. From here, we've got a fuel pump on board. Some aircraft have fuel pumps, other not. We have a beacon light, landing light, our taxi light, our navigation light, our strobe light, which I'm going to show you in the taxi exercise. Where are we going to use which light where? And from there on, we've got what's called a pitot heat. So if it's cold outside or potential freezing conditions, we can actually switch on a heater inside the pitot, which then will allow us to continue flying. Avionics, this is our avionics setup stack here. I'll turn that on in a second and get to that from now. We've got our throttle control, so we are then either adding power or reducing power, as well as our mixture, which control the amount of fuel flow into our carburetors. Same principle. Some aircraft, this is now fuel injection aircraft. Some other aircraft, there's also a lever right here. This is called your Cockpit for reciprocal piston engines that doesn't have fuel injectors. Whenever you are descending or flying through cold weather, then you have to apply a Cockpit. From here we've got then electrically driven flaps. This you can just push down and move about. And then for if we get cold, we have cabin heat to pull. Then actually our heat comes through this sections here, but we do not recommend using heat, as the heat is taken from the exhaust heat, and also to avoid carbon dioxide poisoning. But you're more always than welcome to use cabin air, which is put in nice fresh cold air from outside. Moving down, some aircraft still have handheld radials, and this is your trimmer that will get you into the straight and level exercise. And from here we've got our fuel selector. Now on this particular aircraft we've got a fuel selector off switch, and if we want to fly we'll put it on. All the versions of Cessnas, they actually have a 4-point fuel selector. This one has either right, both tanks selected, or the left, where others they do not have an off cut pull switch like this one, where it actually you turn this knob and it shows towards the back, towards your seats, and that's then in the off position from there right on. Perfect. Then lastly, let's quickly look at the radios stack. So we'll quickly put on the battery, throw on our radios from here. Top section is just where we control on which COM we want to use. When I say COM, we've got, as you can see, we've got referring to this as COM1, this top radio, both two radios, and then the second line, this is then referred to as COM2. Furthermore, this is the main ones we'll be working from, and then later on we will actually then get into your ADF. So what's happening with the ADF is they'll give you a frequency, and then you put the frequency in here, and then you can pick up the NDB towards fly tube. Going down, we have your transponder. In South Africa, when flying, the default squawk code is 2000. When we are not flying, we set it to off. When the aircraft is started or taxiing, we'll put it on standby. Once entering the runway, we will put it on alt for altitude until we've landed and vacated the runway. We will put it back on standby. And then this bottom part here is just the autopilot, but we're not going to use this in our lessons. So let's quickly look at what the radio knobs and frequencies that's located on actually shows us. So on top you would plug in your pilot's headset. On this particular one, the volume control for you and your co-pilot is situated on this first knob. So this is just to select the volume of when your co-pilot is talking to you. Then the one at the back is called your squelch. Now squelch, if you plug in your headset, you'll sometimes hear your when you're talking over the radio, it's almost going to sound like you have this static noise, or it's going to sound like every third word is coming through, and you don't want to you want a nice stable speech when you're talking. So then you just adjust that squelch. So what we do is we basically you put on your headset, put it to loud, and then you set up your volume and squelch for yourself on this side. The co-pilot or instructor or person flying with you will do the same on this side for them, so they can then decide the volume they want to hear you at. Then for ATC or air traffic control, their volume is set with this button from here as well. Sometimes when you get in the aircraft, you'll start up your avionics, you'll see there's nothing displayed on the radio stack. From there, just turn the on switch, which is also the volume control, and then you will actually have your frequencies. So the frequencies on the left hand side, this is the frequency we are currently on and using. If we want to talk to the air traffic controller, there is a button on our flight yoke that we actually press, and then everybody can hear us on that frequency. Now the frequency on the right, this is our standby frequency. So if I'm knowing I'm flying from one part to another, or if I'm using a ground frequency and I need to go over to tower, then I can set it to standby, because if it's time to change over, I can just simply click the change over button and my frequency is immediately set. So then I don't have to struggle to set my frequency while actually talking. So how do I then actually set my frequency from here? Same, the small knob on the front is going to set your right frequency, and then the frequency on your left hand side can be set with the bigger knob. And as you can see, this one is now set on 123 decimal 075. We never say point or comma in aviation, we refer to it as decimal. And then I'll say this is nav 1 that we're gonna com 1 that we're gonna use. Should we get radio failure or it goes out for another reason, we can then utilize com 2. All that we have to do on the top, press com 2 and turn off com 1. Then we'll now be using com 2. The reason, another question some of you might ask me is, why can I press both of them? And what's it is, you can actually set up both of these communications where you can press both com 1 and com 2. So if you are flying near a borderline where two communication frequencies are, where one guy changes over the next, then you can actually monitor. But when you speak, just make sure you are on the correct frequency or communication stack. Then on the right, this one's is for the VORs, these instruments right here. So this is also frequency set, and this will actually get into much more detail when we get to exercise 18. So from here we do not actually then select where we which one we want to use. Nav 1, once you press this and this is set to a specific station, it will actually give you a Morse code that comes through your headset that we need to identify, just as a quick reference. And then the same with our ADF that we do. And as you can see, this one, once we have an ADF, it also shows you nautical miles, how far away you are from the station, and then how fast you are flying in knots. And then if we're flying towards the station, it will show us the minutes until we actually reach the station, or a station from that side. Perfect. And then this is our tutorial for today. I'll see you guys back for lesson 2 shortly. We're gonna just run through a quick checklist, as well as how to actually start the aircraft in the correct manner. Thank you guys for watching. Subscribe to my channel, and I'll see you tomorrow with the next video. Have a good day.